All right, I hope you had a good weekend. Couple things real quick about your tests. They are graded. The scores are on the Synergy that you can see. Once everybody's test is submitted by the deadline, I'll make a video of the answers. That way you can go through and see which mistakes you made. As far as grading it, I look through, tried to give you a percentage of points for doing part of it correctly. The problems that you guys do now are longer than just like an addition problem that you're right or wrong. Part of it could be that you did the steps up to a point right. So just go through that. As far as what it will do is when I post the video, that way you can go through and see which mistakes. So save your answers and go through and you can correct them, and that will help you study. Tests were really good overall. I know some wanted to score a little bit higher, but I think everybody's passed so far, so that's a good sign. Some, like I said, the scores are a little bit lower than they want, so that's good. But that way you can go through and kind of look at what you missed and fix those corrections as we go on. As far as another thing with that is make sure you're writing your problems down correctly. One thing I did allow for this first test, because I know we're getting used to this online thing, is I noticed a few wrote down the problem wrong and then solved it right from that. So I didn't count that off, but you're going to want to make sure that you start to make sure those corrections, that you write them down correct. You're going to notice that once I go through and answer the problems, you're going to notice, oh, I didn't get the same answer. It's because you wrote down, you started the problem wrong. So check that, be very, very careful. That's why I'm doing them as photos, so that you can just bring up the photo and look at the test that way and not writing them on the board. So be very, very careful on copying those. If you're copying them straight to your paper, if you're printing it off and then doing them, that'd be one way to make sure you're writing them correctly. What I'm going to first start with today is this is also some pre-algebra review, because now we're going to really get into the meat of solving. So far we've done combining like terms and PIMDAS and simplifying and stuff. We've not really been solving for the letter. So I'm going to do what kind of like a crash course, kind of review. I know it's going to seem kind of quick, but like I said, if you need to slow down the video and go back and look at it, feel free to do that. That's what's nice about these videos. You can go back and kind of break it down at your speed. But I'm going to kind of do a quick overview of solving. I can't spend that much time on it because it's a prior class and we need to get to the material that we have to cover for this class. But I didn't want to just start cold, where some have not seen pre-algebra in a little while. So let me put some examples up first and talk about them. First thing I'm going to start with is one-step equation. Okay, and some of you guys are breaking out into sweats like, oh my goodness, I remember doing this in pre-algebra and I hated it. But hopefully you can kind of see it again. And I think as you use it and continue to use it, it gets a little bit easier. But one-step equations mean that in one step you solve a problem. Okay, you only have to do one thing and you solve. Now I'm going to put a problem up there that we could probably solve in our head without even doing algebra. If you break this problem down, okay, we are just trying to find out what's missing to make this a true statement. When we learned algebra or math in elementary, our unknown was always over here, meaning we just were trying to find out what the answer was, and the unknown space was always right here. But as you know, in algebra and pre-algebra, as you get further into math, the unknowns are in different spots. The things that could be changed and that you're solving for is not always at the end. This we learned from, early on in math world, maybe second, third grade. When you add these together, you get 12. Okay, and you're putting your answer here. With a problem like this, now you already know what it's equal to. You're trying to find out what this missing space is to add. And the reason why we use letters instead of question marks is because you could have multiple unknowns and all the question marks look the same. With letters, you can differentiate, like an X and a Y is different than each other. So you can know which one's missing. So in this case, we're trying to solve what's missing over here instead of just trying to find the answer at the end. Now in our head, we could probably do this one and know that if I added 5 to 10, I'm going to get 15. But we know as the problems get harder and harder, you can't do them in your head. You have to do the processes to solve for these equations. And so we learned how to isolate the variable. And if you want to watch extra videos and kind of do some research on your own, if you type in isolate the variable, you're going to find just videos all over the place for that, okay? Isolating the variable, okay? That means you're trying to get the variable by itself. You're trying to isolate it. That term has, now that I say it, has never resonated more than right now. We know what isolating, you know, having to completely get by ourselves. And so it's like these commercials, it's like every other commercial is about isolation and being alone. But anyway, so this is not one of those commercials. Basically, we want to get this variable by itself, okay? So that means we need this to go over here, to move and isolate this by itself. So in order to get this away, we need to make it a 0. We need to get rid of it. So instead of adding 10, if I subtract 10, that's what we learned about the opposites. That's gonna cancel those out. 10 minus 10 is 0. But if we do that on this side of the equal sign, we have to do that on this side. Okay? So if I do minus 10, I have to do minus 10 over here, and that's where we get our 5. Now, like I said, I know this is kind of crash course. There's several things I skipped through that, but that's because we don't have the time to go back completely with a complete pre-algebra lesson. So just know if we added 10 and the opposite, we subtract 10 and we get 5. And that's how we isolate and solve for this variable. And we did it in one step. That's why this is a one-step equation. We moved the 10, we were done. Okay? That can even be if it's written in another order, so like the same kind of problem, but now the variable is on this side of the number. We switch places, but it's still a positive 7, and we still need to get that over here. So same thing, instead of, even though we're adding the v, we want to get this to be 0, and so if we subtract 7, that's going to cancel out, but we have to subtract 7 over here. And the only thing now is, instead of writing positive v, just by writing v, it's a positive v. Okay, so I don't need to bring that plus sign down. Over here, we subtract, and we get 2, and so the answer to v is 2. And we can check that. We can always check our answers with variables, plug it back in, and say 7 plus 2 should be 9, and it is. Okay, so no matter which side the v is written on, it can do that. Also a one-step equation. With subtraction. Okay, so we've got this problem here. Okay, this is just like the addition one, except now we're subtracting. In one step, we can solve this by making this 0. So instead of subtracting 12, instead of a negative 12, if I add 12, it's going to cancel that out. But that means I have to add 12 over here, and you get 20. Okay, you can check it by doing 20 minus 12 is 8. So that gives you that correction there. Same thing if this, now this actually almost becomes a two-step problem. It's still kind of categorized in the one step, but here I'll show you why we kind of could say it's a two-step. I've switched places like I did with the addition, and I want to get rid of this, so I'm going to subtract 10. So I'm going to subtract 10, except now I've got, okay, so this is going to be negative 6. 4 minus 10 is negative 6. I can't leave this negative, okay? I can't leave my variable negative and say I solve for it. So however you look at this, you could say you're multiplying by negative 1, or you could say because this is negative 1y, you're dividing by negative 1. Okay, if I divide this, then I got to divide this by negative 1. And so what that does is it cancels out the negative, okay, because a negative divided by a negative is positive. Same thing over here, a negative divided by a negative is positive. Okay, I think it's just as easy as the way I always do it is if I want to change the sign over here to a positive but keep my y the same, then I just change the sign over here. Okay, so if this, you know, this becomes positive, then this became positive. If it had been something like this, okay, if I change the sign over here, then I got to change the sign over here. That's, to me, just as easy to remember. Okay, but either way, you're going to end up with y is 6. We can plug that back in. 10 minus 6 is 4. Okay. Multiplication. So let's say I have this. Okay. Still a one-step problem, except now I don't want this to, I want to isolate this. I still want to isolate this. But if I don't want this to become a 0 anymore, because if it's 0 times x, everything disappears. I just want the 3 to disappear. So instead of multiplying by 3, which is what's happening when you write two terms by each other, see it's 3 times x, then I'm going to divide by 3. The opposite of multiplication is division. And if I divide this side by 3, I have to divide this side by 3. Okay? And so my answer is 4. I could plug it back in and do, my original problem was this. I could plug it back in and go 3 times 4 is 12. 12 equals 12. Okay? So instead of multiplying by 3, I divide by 3, and I get x is 4. That's even true if it's negatives involved. Okay, so let's say I got 2x equals negative 24. Well, when I divide by 2, because instead of multiplying, then this is a negative divided by a positive, so it's negative 12. My answer is negative 12. So the negative rules still apply in this, okay? Last one is division. So let's say I'm dividing by a number, okay? So I'm taking this number and I'm dividing it by, once again, I don't want this to be 0 because that would be, you can't have 0 on the bottom of a fraction anyway. So I don't want this to be 0. I just want the x to remain, and I want this to be a 1. Well, instead of dividing something by 5, if you multiply it by 5, okay, which I could go through, in pre-algebra we talk about how this becomes 5x over 5, and that becomes 5 divided by 5 is 1x. To me, at this stage of the game, as you're using it, just know if the opposite of division is multiplication, then these cancel out. But if I multiply this side by 5, I have to multiply this side by 5. Okay? And x is 20. If I go back to my original problem and want to check my answer, I plug in 20 here. 20 divided by 5 is 4. Okay? Same thing with negatives. Okay, if I've got y over negative 3 is 10, well, instead of dividing by negative 3, I'm going to multiply by a negative 3, and y is going to be, those cancel out, that's why we did it, and y is going to be negative 30, okay, because 10 times a negative 3 is negative 30. We can check that out. See, negative, if I plug that in for my y, negative 30 divided by negative 3 is 10, okay. Said very quick, but if you need to go back through and look at those are all your one-step, really, examples. Two-step, okay. Let's say we have 3x plus 4. So now they get a little bit longer, equals 22. So I call this two-step because no longer can we just do one thing and be done with it. We have to do two things. In this case, we have to move the 3 and the 4. And if I go to division, I'm going to have to divide this whole thing by 3, and I end up having a fraction. I don't want to do that first. It's very, you can do it, but it's very hard. It's a lot of extra work. So what I can do is, if I want to move this 4, let's do that first. So all we have to do is subtract it. So I'm still left with 3x, and over here I'm left with 18. Okay? Then, now it's a one-step. I divide by 3, and x is going to be 6. Okay, so it took me 2 steps this time, but there was an easier order to do it, and so as long as you remember to do that first, it kind of helps you. Let's look at another 2-step. I'm going to put these two up together so that you can see the difference. So y over 3 plus 5 equals 15. And then the other problem is x plus 9 over 4 is 7. Now, one thing I want to draw out, the difference between these two problems, and let me go ahead, just so we keep them separate. The difference between these two problems is this one almost looks the same. It's got a fraction, it's on top, and we've got an addition, but this part of the addition is not in the fraction. This one is in the fraction, which changes the order in which we want to do it. If it's off the fraction, we can easily move this. We can easily get rid of it, and that's what we're going to do first. We're just going to subtract it like we would if it was there by itself, and we're left with y over 3 equals 10. Okay? And then all we're left to do is, instead of dividing by 3, to multiply by 3, and we get y is 30. Okay, so the first thing we did was move the 5 because it was very easy to move. Then we were just left with one step. Here, we can't just move the 9 by subtracting it because it's part of the fraction. Okay, we'd have to move 9/4, and then we'd have to deal with fractions. So we can't move the 9 first in this case, but we can go ahead and get rid of the fraction, get rid of the 4 by multiplying by 4. Instead of dividing by 4, we multiply. That means these disappear. We've got to make sure to multiply this by 4. Don't forget that. And all we're left with is x plus 9, because these disappeared. And this is 28. Okay, and now we can move the 9, because it's now been separated from the fraction. And we get x is 19. 28 minus 9 is 19. Okay, so I want to put those two up together to show the difference. So there's some two-step. And then the last thing is variables on both sides. Okay, variables on both sides. So this is 3x, let's put 3x plus 7 equals 2x minus 2. Okay, and this is different because now we've got a variable over here and we've got a variable over here. Now, right now, all we're solving for is one variable. Okay, so as we go on in algebra, we're going to have like x's and y's and z's and more than one letter in a problem. But right now, this is where we left off in pre-algebra. I still need to isolate the x, but now do I isolate it over here or do I isolate it over here? Now, I'm going to make a big change for those that have had me before. Those that had me before, I've always taught that it really doesn't matter which side you solve it. I always try to keep it positive. I've learned just over time that as far as quick as we're going and the different classes we're having, students sometimes get caught up like trying to pick a side. I'm going to now, as I show this and as I do this, we can always make it a side so that we know which side we're going to move it to. That means we're going to have to deal with some negative variables, but I think it'll help in the long run kind of keep everybody at the same pace. So in this case, from these point on, I'll always move my variables to the left side. So I'm always going to get my x's or y's or whatever I'm trying to solve for over on this left side. Okay, not a huge actually change. I shouldn't have said that because I really was like, oh no. But it is going to be something that I will try to follow now as much as I can. So if I end up not doing it, you can call me out. You'd be like, hey, I thought you were going to do this. And I'll just be like, no, you're mistaken. I think you're wrong. No, I'm just kidding. I wouldn't do that. But basically, if I want to move this over here now, that means I don't want it to be left as x. So this is not where you divide by 2. Because that's still going to leave. If I divide by 2, it just becomes 1x. And I still have an x over here. I want to move the whole thing. I want to get rid of it over here. So if I subtract it, 2x minus 2x makes it disappear. Makes it become 0. Makes it become nothing. It's not a magic trick. It's just, I've made it leave. Now, if I do that, though, over here, I have to do that over on this side of the equal sign. Remember, the equal sign is the divider. It's the fence, that one side and one side. So once I subtract this, then I'm left with x plus 7. See, 3x minus 2x is x plus 7 equals negative 2, because that's what's left over here. And now I've got a one-step problem where I can move the negative 7, and I get negative 9. Negative 2 minus 7 is negative 9. So I've moved everything, moved all the variables to the left side, and then started isolating it from there. Okay, let's do another one of those. Let's say I have, and I'll do one that we have to do some division. So 5x plus 2 equals 3x minus 4. Okay. So sticking to my new rule of moving this over to this side, I'm left with this. Okay, I made this disappear, moved it over here. 5x minus 3x is 2x. Still have my plus 2, still have my minus 4. Now I want to isolate this x, and I've got a two-step problem, and it's easier to move the negative 2 first. So that makes that disappear. This is going to be negative 4 minus 2, which is negative 6. And then all I have left to get rid of, now this time I don't want to subtract 2x, because that makes everything disappear. I have no more variables left in the whole problem. I just want to divide by 2. Okay, negative 6 divided by 2 is negative 3. Okay, so I know quite a bit, but run it back, watch it, make sure you're being organized too, going step by step. Okay, you know, when I do these problems at home, not that I sit at home and do math problems, even though I do that from like 10 to 1 in the morning. I just sit and do math problems for fun. But anyway, if I'm doing these problems, then I can skip steps because I do them so often, and I just do maybe 2 steps and I'm done with the whole thing. Make sure for right now as you're practicing this that you're going through and doing them step by step, okay? All right. So let's do one more, and I'll show you what I mean about now I'm going to have to deal with negatives if I follow my left side rule as far as always moving to the left side. In prior times, I would have moved this over here and solved because it doesn't matter. But because I'm sticking to this new rule, I'm going to move the 6x over here, okay, which makes this negative x, or negative 1x, or we don't write negative 1, but it's negative x, okay? And now I'm still going to, and see, this stayed. Now I'm going to move my 7. I still have a negative x. This is going to be a negative 2 plus 7, which is 5. And now, this is what I was talking about. If you have a negative x, you need to change the sign to over here, and x is negative 5. Okay? Like I said, crash course of solving equations. Here's why we need to use these right away. Is the first thing we're going to look at in the algebra part of this is ratios. Okay, ratios, we've got to use a couple times. How I talk about ratios is, and we actually use this, you probably use this a lot in your life, and you don't really necessarily think about it being algebra or even write it down. You're just constantly probably just figuring out, well, if I need to double something, what is that? But an example is if you're baking or something, okay? And if you took 2 cups of flour, and it took you 2 cups of flour to make a batch of 50 cookies. Okay, now I'm super hungry already. That's another thing about this isolation thing is the fridge is just always beckoning. You know, it's like, hey, what else can I do? Oh, I can eat again. But basically, if you've got 2 cups of flour that you have to use to make 50 cookies, then to use a ratio means, well, how many cups of flour then would I need to use to make 100 cookies? Okay, let's say I want to double that. Well, we already, like I said, we probably don't write it down on paper or think that we're using algebra. But ratios in algebra means, okay, well, if I doubled that, I wanted to double the amount of cookies, then I have to double this. And so instead of 2 cups of flour, it took me 4 cups of flour. Okay? So we're kind of doing that already in our head, or doubling. The problem is in life, even, and especially in algebra problems, they're not this easy. It's not just going to matter of simply doubling something and solving it. So we have to come up with a process or a way to work these kind of problems that you can then apply to any example. I use this example in class. I'm going to kind of condense it and also leave out some information because I know it's being recorded. But basically, and not that it wasn't true before, it's just like, I don't know if I want to share this whole thing. But I had a relative call me one time and was like, hey, we're trying to do this thing at work, and we're trying to figure out if this changed, and now we've got, you know, the amount changed that we need to do this by, then how do we know how much to change what we're doing, the part that we're doing? And if my first reaction was like, oh my goodness, I don't want to mess this up because, like, is it dangerous if you get it wrong? And I was assured that no, the computer, you know, that they use makes sure that they don't overdo what they were supposed to do. But they were just trying to figure out estimates of what they needed to do. And I said, well, it's a ratio problem. If you're changing the outcome, then you just got to change your input in the same ratio, in the same proportion. And so I showed him how to set it up, and then you can go from there. And of course, once he said, "Oh yeah, that's right," and he remembered. So not that it was a guy; it could have been a girl relative. But anyway, as far as this ratio, if I had how I would set that up is if it took me 2 cups of flour to make 50 cookies. Okay, and this is very, very important that to make sure the ratio works that you set it up the exact same way over here. So if I use the flour on top and the cookies on bottom, and let's say this is what I was trying to find out, well then I'm going to put my unknown, and with algebra we use a variable. Okay, my unknown type, see I kept flour up top, so flour and flour, and then cookies and cookies stay on the bottom. Okay, so now I've got my 2 fractions. 2 cups gives me 50, then how many cups gives me 100. I set them equal to each other, and then how you solve a ratio proportion is you cross multiply. So 50 times x is 50x. Okay, so I cross multiply there, and I'm going to cross multiply over here. 2 times 100 is 200. And they're still equal to each other. So 50 times x is equal to 200. Now to solve for x, I'm going to divide by 50. It's a one-step problem. X is going to be 4. Okay, 200 divided by 50 is 4. So that's how I would solve doing this ratio. And you say, well, why would I ever use a ratio? Well, let me use it as this example. Let's say I was doing a problem of 30, this is kind of hard to come up with something, but 30 tablespoons of, I don't know why it would take 30 tablespoons of anything. Let's make something really salty. 30 tablespoons of salt will give me the outcome of 120, we'll say biscuits. We're going to have really salty biscuits. Okay? So 30 tablespoons of salt will give me 120 biscuits. Well, then how many tablespoons will give me 720 biscuits? Okay, this one's not as quick to be like, oh, I know what that would be. And this one's actually going to come out even too. I did this one earlier. I was like, oh, that came out even when I was doing my math problems for fun at 10 at night. But when you go to solve this, it's not as quick as just doubling it. So if I set it up the same way though, 30 gives me 120, then how many gives me 720? Okay, I can now cross multiply and solve. So I end up with 120x, and then 30 times 720 is 21,600. No, I did not just do that in my head. I had done one earlier. Okay. Okay, but I cross multiplied this and I cross multiplied that. Okay. Now I divide both sides by 120. Now this I will do in my head, and I get x is 6. Okay. Oh, sorry. No, I shouldn't have done it in my head. I was thinking about what I did to it. It's 180. Okay. Sorry. Edit. Rewind. Back up. If we were Blockbuster, we'd rewind it. But basically, x is 180. The reason why I was thinking of 6 was, okay, the answer is 180. If it took me 30 tablespoons to make 120, it's going to take me 180 tablespoons to make 720. Okay, because when you divide this by this, you get 180. Well, what that means is I multiplied this by 6. It took me 6 batches to give me this. Well, then I've got to multiply this by 6 in proportion, and that's why I come up with the 180. But you probably didn't recognize that this was 6 times that. That's why you have to set these up. And not all of them are going to come out equal in real life. You could get decimals, fractions, and so, this is just examples of where they don't always come out even, okay? This right here, this will be the kind of your first portion of your daily work today. It's kind of a longer video. I am going to also be posting a worksheet or some problems, probably in the form of a picture, for your second half of today. The reason I wanted to leave you some time and not shoot a video of all new material is because I'm going to post some photos of some equations, 1-step, 2-step, probably even some variables on both sides. Those take a little while, so you're going to use your class time to be working through. I want to give you some of this time, not make the video as long, so that you could do those problems for the second half. Then we'll, like I said, we're going to be moving quick as far as going into the finished unit by unit now, and so I'll be keeping you updated. But just as soon as I get all the tests in, that's the next announcement. As soon as I get all the tests in, I'll post answers so you can check your answers with the prior test. Okay? Thanks, guys.